Good afternoon, Year 7. For the start of today's lesson, I would like you to think about the problem that we have in front of us. So, we have 1 kilogram of feathers and we have 1 kilogram of rocks. Which do you think would have the greater volume? And which do you think would have the greater mass? And why would this be? Give yourselves a minute, 2 minutes if you need, to have a think about the problem and to think of your answer. So, now that I've given you some time to think, okay, we're going to tackle the second part of this question first. So, which do you think would have the greater mass? Well, 1 kilogram of feathers weighs exactly the same as 1 kilograms of rocks. They have the same mass. Okay, now let's think about the volume. Now, to get 1 kilogram of feathers, you are going to need a lot of feathers because feathers are very light individually. So to get a kilogram of feathers, you're going to have to stuff a lot of feathers into a bag. And that bag is going to be much bigger than what 1 kilogram of rocks will look like. So the volume of 1 kilogram of feathers is going to be much greater than the volume of 1 kilogram of rocks. So why? Well, there is a key word that links all of this together, and that key word is density. So, can you please write down the title today, which is density? You can add the date. It is the 15th of June, and our learning objectives are going to be the following. We're going to introduce density triangle and complete some practice questions. And we're going to look at an experiment using the displacement/Eureka, where you can find the volume of an irregular object and hence its density. Now, we might not get onto this in today's lesson, but we will definitely talk about it towards the end. So, as with any new topic, we need to have our definition of what density is. Now, before we get onto our definition, I would like us to take a look at some different substances. Now, all these substances are made up of a volume of 1 centimetre cubed. We have wood, we have water, and we have iron. Now, 1 centimetre cubed of wood weighs 0.5 grams. 1 centimetre cubed of water weighs 1 gram. And 1 centimetre cubed of iron weighs 8 grams. So we now have 3 substances that all have the same volume, but they all have different masses. So which has the greatest mass and therefore the most dense? Well, obviously the greatest mass is the iron. It weighs 8 grams. Now, our definition for density can therefore be the following. The density is equal to the mass per unit of volume. So the density of an object is its mass per unit volume. Now you'll see that there's a pencil in the bottom right hand corner, so can you please note down the information from this slide into your notes, please. Right, so now we have our definition for density, which is mass per unit volume. I want us to apply our knowledge to the following problem. So, we said that density is equal to the mass per unit volume, which is the same as the mass divided by volume. Now, mass is measured in grams or kilograms, and our volume is measured in centimetres cubed or metres cubed. So therefore, density must be measured in grams per centimetre cubed or kilograms per metres cubed. So now we have our units for density. Now, a bit like our speed, distance and time, there is also a triangle to work out density, mass and volume. So density is equal to the mass divided by the volume. If we wanted to work out the mass of an object, we would need to know its density multiplied by its volume. And the final one, if we wanted to know the volume of an object, we could work that out by having the mass divided by the density. Now, before we move on to looking at a problem, I would like you to write down what you can see on the slide at the moment. So density equals mass and volume. Can you please add the units in for those, and can you also please draw out the triangle? Now, once you've done this, fantastic. We now have an example question for us to think about. So the question is, liquid water has a density of 1 gram per centimetre cubed, while ice has a density of 0.92 grams per centimetre cubed. Now, both are obviously made up of water. However, one is in liquid form and one is in solid form. You'll notice that the density of ice is slightly less than that of water. Now, if you think of a cup of water, if you add ice to it, what does the ice do? Yes, it floats. Okay, so if it's less dense, an object will float. So, now we need to calculate the volume occupied by 250 grams of each. So, remember, we know the density, we know the mass, we just want to work out what the volume is. So to work out the volume, we need to divide the mass, which is 250 grams, divided by the density. So for liquid water, it's going to be 1, and for ice, it's going to be 0.92. So your answer should look like this. The volume of water is equal to the mass divided by density, so 250 divided by 1, which is equal to 250 centimetres cubed. The volume of ice, slightly different here, it's 250 divided by 0.92, which gives us a volume of 272 centimetres cubed. Can you make sure that's also added to your notes? Thank you. Okay, on this slide, I would like you to have a think about which is more dense. You have 3 different examples on the top left, top right, and in the bottom middle. Give yourself some time and just have a think about which one you think is more dense. In the first example, you will work out, or hopefully work out, that A is the more dense than B, because the particles are closer together than they are in B. On the far right hand side, B is more dense, but the particles are tightly packed together with the same mass. They're tighter, so it's going to be more dense. And at the bottom, they are exactly the same. So neither is more dense. Okay, moving on to this next slide, you'll see that there are 3 questions for you to have a go at. Remember, practice makes perfect, so make sure you read the question carefully, write these out in your notes, follow the steps that they have given, and make sure you complete all 3 before moving on. Now, like many things in science, a lot was discovered thousands of years ago, and Archimedes and the crown is no difference. Now, Archimedes was a great scientist who lived more than 2,000 years ago in a Greek city called Syracuse. He was very clever at inventing and understanding how things worked, so King Hiero needed his help many times. Take a look at the YouTube video linked below to see exactly what the story was. The video is only about 4 or 5 minutes, so it shouldn't take you too long. Now that you've watched the video, this next slide should make a little bit more sense. So now we have the density of gold, and we have the density of silver. So for the same volume, because gold is more dense and has more mass, okay, therefore it would tip the scales. So for it to be equal, you'd need to have a bigger volume of silver to make sure it has an equal mass to the gold. So the mass of the crown was 2,000 grams, and it should have had a volume of 100 centimeters cubed. The actual volume of the crown was 150 centimeters cubed instead of 100. So was it pure gold? And the answer to your question is no, as you saw in the video. So how do we work out the density of a regular solid? Now, we know that density is the mass divided by the volume. So we need to find out what the mass and the volume are to be able to work out what the density is. So, how do you find the mass of an object? You put it on a balance. So if you find the mass of a solid on a balance, it might equal 240 grams, let's say. How do you work out the volume? Well, the volume of an object is the 3 lengths of that object. So you need the width, you need the height, and you also need the length. If you multiply these together, you will get the volume. Once you know, obviously, the mass and the volume, you can measure the density by dividing the mass by the volume, which in this case is going to be 240 grams for the mass divided by 24 centimeters cubed for the volume, which would leave us with a density of 10 grams per centimeter cubed. Now, I'd like you to write out that example in your notes as well, because it is very important. Now, that method is all good and well for regular shaped objects. However, finding the density of an irregular shaped solid is slightly harder. And that comes because it's very difficult to work out the volume of an irregular shaped object by measuring it. So you have to do something different. Finding the mass is exactly the same. You can place that object on a scales or a balance and find the mass easily. But finding the volume is a little bit harder. And this is what you need to do. Now, obviously, you won't be able to do this at home, but there is a method using a Eureka can to find the volume. Now, as I said before, you'd find the mass of the solid on a balance. The mass of the object we have here is 440 grams. Now, what you would do is then add water to the Eureka can up to where it just overflows the spout. Now, water will leave until it is completely level. You would then place a measuring cylinder under the spout, and you'd add your object into the Eureka can. When you add your object into the Eureka can, the volume of water will rise up, as in the object will displace the water, and some water will leave the spout into the measuring cylinder. Once all the water that has been collected, you can then obviously measure how much water has been displaced. And this will give you the volume of the object in the Eureka can. So in this instance, the object has displaced 40 centimeters cubed of water. So we now have the volume of the object. Now, from this, you can calculate its density. Again, it would be the mass divided by the volume. So 440 divided by 40 will give you a density of 11 grams per centimeter cubed. Please, can you add all of this information to your notes as well? This is how you measure the density of an irregular solid. And finally, for your notes today, this is the plenary. There are 5 sentences. You need to write out the sentence using the correct word in the brackets. There are 5 sentences. Make sure they're all written in your book. Okay, and make sure you put the correct word in each sentence. Once you have completed the plenary, your next task, as you'll see from Firefly, is there is going to be a worksheet to complete. This worksheet is on Firefly. You can download it and complete it on your computer. You do not need to send it to your teacher today. Okay, it's just a worksheet that reinforces everything that we've looked at today. So take your time, download the worksheet, complete it, and save it on your computer. You do not need to send it to your teacher. Thank you very much for listening. I will see you all tomorrow. Thank you.